Good morning, students. Today's topic of discussion is red cell indices. We can determine the values of hemoglobin, RBC count, and PCV in laboratory. But the basic values of hemoglobin, RBC count, and PCV do not give us any information about the condition of an average red cell, such as its volume, hemoglobin content, or its percentage saturation with hemoglobin. But an average red cell's volume, hemoglobin content, percentage saturation with hemoglobin can be calculated indirectly from the values of hemoglobin, RBC count, and PCV. And these are called red cell indices. These include mean corpuscular volume or MCV, mean corpuscular hemoglobin or MCH, mean corpuscular hemoglobin concentration or MCHC, mean corpuscular diameter or MCD, color indices. Apparatus and materials required for those used for estimation of hemoglobin, RBC count, and PCV. Mean corpuscular volume or MCV. What it is? The MCV is the average or mean volume of a single blood cell expressed in cubic micrometers or femtoliters. It is calculated from the following two basic values: red cell count in million per cubic millimeter and packed cell volume or PCV in 100 milliliters of blood. Derivation of the formula. We know the value of RBC count, which is 5 million per cubic millimeter of blood. Therefore, we have to calculate the packed volume of RBCs in 1 cubic millimeter of blood. Since PCV is 45%, the volume of packed cell in 1 cubic millimeter of blood is 0.45 millimeter cube. Number of red cells in the same volume of blood, that is 1 cubic millimeter, is 5 million. There are 5 million or 50 lakh red cells in 0.45 cubic millimeter of blood. Therefore, the volume of one red cell is equal to 0.45 divided by 50 lakh cubic millimeter, because 1 millimeter is equal to 1000 micrometers. The MCV is 0.45 into 1000 into 1000 into 1000 divided by 50 lakhs is equal to 0.45 into 1000 divided by 5 is equal to 90 cubic micrometer. The normal range of MCV is 74 to 95 cubic micrometer. Formula of the MCV can be expressed as PCV into 10 divided by RBC count in million per cubic millimeter. Mean corpuscular hemoglobin or MCH. The MCH is the average hemoglobin content in a single red cell and is expressed in picograms or in micrograms. It is calculated from the following basic values: RBC count in million per cubic millimeter and hemoglobin in gram percent. Derivation of the formula. 1 centimeter is equal to 10 millimeter. 1 cubic centimeter is equal to 10 to the power 3 cubic millimeter. Therefore, 1 milliliter is equal to 10 to the power 3 cubic millimeter, and 100 ml or 100 milliliter is equal to 10 to the power 3 into 10 to the power 2 is equal to 10 to the power 5 cubic millimeter. Since 1 cubic millimeter blood contains 5 into 10 to the power 6 red cells or 5 million red cells, 100 milliliter of blood will contain 5 into 10 to the power 6 into 10 to the power 5 red cells, that is equal to 5 into 10 to the power 11 red cells. Since 1 gram is equal to 10 to the power 12 picograms, so 15 grams is equal to 15 into 10 to the power 12 picograms. Thus, the hemoglobin content of 5 into 10 to the power 11 RBCs in 100 ml of blood, which we have calculated in the previous slide, is equal to 15 into 10 to the power 12 picograms. The hemoglobin content of one red cell, that is mean corpuscular hemoglobin or MCH, will be 15 into 10 to the power 12 divided by 5 into 10 to the power 11 is equal to 15 into 10 divided by 5 is equal to 30 picograms. And the normal range of MCH is 27 to 32 picograms. So, the formula of MCH can be expressed as a ratio of hemoglobin in gram per liter and RBC count in million per cubic millimeter. Mean corpuscular hemoglobin concentration or MCHC. The MCHC represents the relationship between the red cell volume and its percentage saturation with hemoglobin. That is, how many parts or volumes of a red cell are occupied by hemoglobin. MCHC is expressed as hemoglobin in gram per 100 ml of blood into 100 divided by CCV per 100 milliliter of blood. For example, if hemoglobin content is 15 gram per cent and PCV is 45%, then MCHC is equal to 15 by 45 into 100 is equal to 33.3%. Normal range of MCHC is 30 to 36%. Derivation of the formula. 45 volumes of red cells contain 15 grams of hemoglobin. 1 volume of red cell contains 15 by 45 grams of hemoglobin. 100 volumes of red cells will contain 15 by 45 into 100 is equal to 33.3% of hemoglobin. That is the value of mean corpuscular hemoglobin concentration or MCHC. Mean corpuscular diameter or MCD. The MCD is determined by direct micrometric measurements of the red cells in a stained film. The range is 6.9 to 8 micrometers. Average is 7.5 micrometers. Color index. The color index is the relation between hemoglobin concentration in percentage of normal and RBC count in percentage of normal. So color index can be expressed as the ratio of hemoglobin concentration in percentage of normal and RBC count in percentage of normal. Or in other words, the color index can be expressed in the following manner. The color index is low in iron deficiency anemia and is high in macrocytic anemias. Normal range of color index is 0.85 to 1.15. Different red cell indices are used to classify the anemias on the basis of MCV or mean corpuscular volume and MCHC or mean corpuscular hemoglobin concentration. The anemias can be classified in the following manner. When the MCV or mean corpuscular volume is within the normal range and the anemia persists, then it is called normocytic anemia. When MCV is below the normal range and the anemia persists, then it is called microcytic anemia. When MCV is above the normal range, then the anemia is called macrocytic anemia. When the MCHC value is within the normal limit and the anemia persists, then it is called normochromic anemia. When the MCHC value is below the normal range and the anemia persists, then it is called hypochromic anemia. Here are the examples of normocytic normochromic, normocytic hypochromic, microcytic hypochromic, macrocytic normochromic, and macrocytic hypochromic anemias. Examples of normocytic normochromic anemias are conditions after acute hemorrhage, hemolytic anemias, acute thalassemias, renal disease, aplastic anemia, chronic infection. Examples of normocytic hypochromic anemia is the condition after chronic blood loss. The examples of microcytic hypochromic anemias are iron deficiency anemia, thalassemias, hypoproteinemia. The example of macrocytic normochromic anemia is deficiency of vitamin B12 and folic acid. The example of macrocytic hypochromic anemia is secondary to the condition secondary to liver disease. These are in short all about the red cell indices. Thank you.